Previous video explained definition of a trigonometric equation, solution set, general solution of a trigonometric equation. Also define principal solutions of some standard equations. Okay, now how to write general solutions of standard equations. If sin x equal to 0, then x is equal to 0 plus or minus pi plus or minus 2 pi and so on. Then the general form of x is n pi where n belong to z. If cos x is equal to 0, then the values of x are plus or minus pi by 2, plus or minus 3 pi by 2, and so on. The general form of x is odd multiple of pi by 2, where n belong to z. Now, third equation, if sin x equal to k equal to sin alpha, where k belong to closed interval minus 1 comma 1. Since sin x is positive in quadrant 1 and quadrant 2, the values of x are alpha, pi minus alpha, and so on. Therefore, the general solution is x equal to n pi plus minus 1 whole power n alpha, where n belong to z. Now go to another equation. If cos x equal to k, that is equal to some cos alpha, where k belong to closed interval minus 1 comma 1. Here we take alpha is principal solution. Alpha is a principal solution. Since cos x is positive in quadrant 1 and quadrant 4, then the values of x are alpha, 2 pi minus alpha, and so on. Therefore, the general solution of this equation is x equal to 2n pi plus or minus alpha, where n belong to z. Now go to another equation. If tan x is equal to k, that is equal to tan alpha, where alpha is a principal solution. Right, here k belong to R, and tan x is positive in quadrant 1 and quadrant 3. Then the values of x are alpha, pi plus alpha, and so on. Therefore, the general form of x is n pi plus alpha, where n belong to z. Now go to another type of equations. If sin square x is equal to some k, that is equal to some sin square alpha. Similarly, in cos and tan, okay, right, then the values of x are alpha, pi minus alpha, pi plus alpha, 2 pi minus alpha, and so on. Therefore, the general solution is x equal to n pi plus or minus alpha, where n belong to z. Now, if sin A is equal to sin B and cos A is equal to cos B, see, this is different from other equations. Sin A is equal to sin B and cos A is equal to cos B, or sin A is equal to sin B and tan A is equal to tan B, or cos A is equal to cos B and tan A is equal to tan B. then the values of A are angle B, 2 pi plus B, and so on. Therefore, the common general solution. Okay, here this is the common general solution for satisfying both the equations is A is equal to 2n pi plus B, where n belong to Z. Now, an important result, the equation A cos theta plus B sin theta is equal to C has a solution if mod C by root of A square plus B square less than or equal to 1. Otherwise, the given equation has no solution. How to derive this result? Let A cos theta plus B sin theta is equal to C. So in trigonometry, entire trigonometry, so this equation is up here. Now immediately divide this equation by root of A square plus B square. Okay, so divide this equation by root of A square plus B square. Now, the given equation can be converted into cos of A minus B form or sine of A plus B form. Therefore, cos of theta minus alpha is equal to C by square root of A square plus B square. Since modulus of cos of theta minus alpha less than or equal to 1, therefore mod C by root of A square plus B square less than or equal to 1 has a solution. Otherwise means mod C by root of A square plus B square greater than 1, the given equation has no solution. Right. Now, some important points to remember for solving any type of equations. Right. See, first one, since the range of sine theta and cos theta is closed interval -1 comma 1. Keep in this mind for solving any trigonometric equation involving sine theta and cos theta. Now, second point, before going to second point, suppose take an example, let x is equal to 2. Squaring on both sides, we get x square equal to 4. That implies x equal to plus or minus 2. Actually, x is equal to 2 is only an equation. But here, minus 2 is an extra solution. So, avoid squaring the equation if possible, because it may lead to extraneous solutions. Now, before going to third point, take one example. Let x square equal to 2x. Now, cancelling both sides x, we get x is equal to 2. But actually, the solutions of x square equal to 2x are 0 and 2. Okay, therefore, do not cancel the common variable factor from the two sides of the equations, because we may lose some solutions. Right. Now go to fourth point. Always denominator is not 0 at any stage while solving equations. Now go to fifth point. If theta is an odd multiple of pi by 2. If theta is an odd multiple of pi by 2, then the equation involved either tan theta or secant theta, then the given equation is not defined. So if tan theta or secant theta is involved, then theta should not be an odd multiple of pi by 2. Similarly, if cot theta or cosecant theta is involved, then theta should not be an integral multiple of pi. Thank you.